Alright, welcome to the Crazy Hat Chemist. Today is the 14th video in the series of 16 on gases, and today we're going to be talking about the density of gases. Here we go. So, gas calculation number 9, density. We're going to determine the density of chlorine gas at 742 millimeters of mercury, 156 milliliters, and 22.3 degrees Celsius. So, the density equation is density equals PM over RT. We actually went over this equation when we talked about the ideal gas law. It's a rearrangement of the ideal gas law. Does anybody remember the formula for chlorine gas? That was just a quick little pause there. Hopefully you remember it. It is Cl2. It is diatomic. Okay, so the first thing that we're going to do in this equation is we're going to plug in the ideal gas constant. So we're plugged in the ideal gas constant. Now we're going to convert our pressure to the units of pressure that are appropriate. That is atmospheres, and that's right there. So we're going to convert the 742 millimeters of mercury, convert it into atmospheres. I'm maintaining 3 significant figures in that as well. Then we're going to calculate the M, that is the molar mass. So I'm going to look up chlorine on the periodic table, find chlorine, and then multiply it by 2 because it is diatomic, and therefore that is that number right there, the 70.906. The units for molar mass are grams per mole. All right, the next thing we're going to do is convert the temperature into the correct units. That's 22.3 degrees Celsius. I'm going to add the 273.15, and I'm going to get 295.5. It's to 1 decimal place. Hopefully got all those correct there. I'm going to plug in all this stuff into that density equals PM over RT. I already got the R in there, so I'm going to plug in the P, the M, and the T. Bam, and I got that right there. You should see that the units of moles cancels out. The units of atmospheres cancels out, and the units of kelvins cancels out. In the numerator, the only units that don't cancel out are grams. In the denominator, the only units that don't cancel out are liters. Okay, we're going to look at number of significant figures here. We got 3 as the fewest number of significant figures on this multiplication division problem. And then we're going to have number units formula for our answer with 3 significant figures. And here we go, 2.85 grams per liter of Cl2. That's chlorine gas. All right, fantastic. Everybody got that? I hope you did. Here it is again. Same problem, but here is an alternate path. There are many different ways of solving these problems sometimes, and here's just another way of doing it. The PM over RT is really a derivation of the ideal gas law. So what I'm going to do is I'm going to take the ideal gas law and solve for moles. Bam! There it is. The first thing what we're going to do is we're going to plug in the gas constant just like what we've done before. Except what we did on the previous slide, if we've already converted our pressure, our volume, and our temperature already. So I'm just going to plug all that into there, and hopefully that works for you. Bam. Okay, you should see that the atmospheres cancels out, the liters cancels out, the kelvins cancels out. In the denominator, it's 1 over moles. I'm going to flip that, and I'm going to get moles. So I'm actually solving for moles of, remember, chlorine, that's diatomic. I have 3 significant figures here, and there's my mole value of chlorine. So that's 6.28 times 10 to the negative 3 moles of chlorine gas. Now recall that density is a mass per unit volume. I don't have a mass right now, I have an amount of gas, so I'm going to convert these moles into grams using the molar mass. We already calculated the molar mass on the previous slide for chlorine, so hopefully we can do that really simply, and this gives us mass of chlorine gas. That also has 3 significant figures. And again, density equation is mass per unit volume. So I'm going to plug in the mass, that is 0.445 grams of chlorine, and then I'm going to plug in the volume. This time I'm going to use the volume that's right there, and that's 156 milliliters. And that's what I've got. I have 3 significant figures in all these numbers, so my answer is going to have 3 significant figures. So I'm going to divide these two. The units don't cancel because it's grams per milliliter. And I got 2.85 times 10 to the negative 3 grams per milliliter of chlorine gas. Now, one thing to note, if you look at the previous answer, it's 2.85. It's a factor of 1,000 off. This answer is a factor of 1,000 off from the previous answer. But the previous answer was in grams per liter. This one is in grams per milliliter. So you need to make sure that you really pay attention to your units. Howdy, partner. It's Taco Tuesday. And that was the 14th video in a series of 16. We are almost done with gases. I can't wait. All right, I'll see you next time. Have a great day. Bye now.